Okay, so tonight we're going to talk about the multiple inheritance issue. Now, I mentioned it last night, but we didn't really get into it. And so tonight we're going to get into it a little bit. The two things we're going to discuss is the diamond problem and the mitigation uh, ways of, how you mitigate it. In Python, it's done by C3 linearization that we're going to talk about because it's the same method used by Solidity. Now, before I talk about that, let's talk about what the issue is. Basically, they call it the diamond problem, or as they say in this article, this Wikipedia article, the deadly diamond of death. Basically, all it means is you've got two classes, or in the case of Solidity contracts, that inherit from one class, and then a fourth class inherits from both the classes. So as you can see here, you got A, B, and C inherit from A, and then D inherits from B and C. Now let's say you have a method foo in B and a method foo in C. D is like, well, which one do I run when foo is called? That's the diamond problem in a nutshell. And again, we're going to talk about how it's mitigated with the C3 linearization. The one interesting thing I learned in researching this is Java, which I think I mentioned did not allow multiple inheritance, thus avoiding this issue. It says right here that it introduced default methods on interfaces. So if A, B, and C are interfaces, B and C can provide a different implementation to an abstract method of A, causing the diamond problem. Either class D must re-implement the method. It could either pick an implementation or it'll be rejected as a compile error. So it does not do, prior to Java 8, did not support it. I didn't realize that they started supporting it in 8, just tend to avoid it. And there are other ways of working around it as well. As they mentioned, you can simply forward the call to one of the super implementations. So let's say you have two classes, B and C, and you have a third class D that you want to inherit from both. You can simply write a method. You can inherit from one and then simply write methods that call in the other one. So anyway, we understand what the problem is. The problem is essentially compiler confusion. What do I do? Which one of these do I pick? That is the subject of the C3 linearization, which is an awful big name. And it's pretty well discussed in this Wikipedia article. But I found that this discussion in this Medium article was brought a little bit of clarity to it. So here's the example they give. Order is the hierarchy which base classes search when looking for a method. Okay, so if you look at C and it's A and B, well, A is first, so it'll print A. It'll call A. And so it inherits from both, and it just picks the first one. And it's seen usually in the dir command. And in the case of D, which inherits from Now in this case, D has its own method, so it calls its method. It doesn't have to worry about the others. But let's say it didn't have, now this is Python, by the way. So the next obvious one is B. Again, B before C. So you get an idea of how it's done. Now they do talk about it. Children precede their parents. If a class inherits from multiple classes, they kept in order specifying the tuple of the base class. Let's see. If you notice here, this is where this gets confusing. Now, if these were the same, it would obviously be A and B, but it does get, in this particular case, it's a bit ambiguous, as they mention. So let's go back to this. Children precede their parents, and okay, we mentioned that. Consistent extended present means how basic handling from the superclass. Inheritance graph determines the structure. Preserving local precedent ordering, visiting the superclass only after the method of the local class is visited, and monotonicity. Let's listen what that means. Monotonic, if C1 precedes C2 in linearization of C, then C1 precedes C2 in any linearization of a subclass of C. So this is why this is a bit unclear, and this is why when you go up here and you look at this, it would call B, because it goes in the order of that D specifies. Now, there is I don't know if they do it here. Go back to the, let's see, yeah. They go through a detailed graph here. Let's see if you can see it. So sometimes it's obvious. A only inherits from O. B, D, and E only inherit from O. Where it gets confusing is, what about K1 through K1, K2, K3, and Z? So they go through this example here. So these are pretty obvious. Now in this case, let's look at K1. So K1 is K1 plus the merge of all these. And if you look at list A, B, C, it's A0, B0, and C0, and A, B, C, because it's ahead. So what you do is you put A here. So you say, oh, A is the best choice, so it goes here, and you still got O. Now, O is not a good, because it's in the tail. So you reject things that are in the tail if you have more than one thing. So the next obvious candidate is B, which is what I thought. So B is the first one. It's not in the tail of anything. And so now you have K, A, and B. And now you have two zeros, C and C with 0. And because it took, remember, when you merge, you take, what you're doing is you take this B, say, okay, I'm merging in B, you stick it in here, and now you've got some zeros, and then you got C. So C is at the head, and then you just merge all these, and since these are the same, just, so now you get this order. And you can do a similar thing in these other examples. This is a good article as well, this Wikipedia article. They gives you several examples that you can follow and see, exactly how it goes. So this is, and they go through an example here and shows you the order. Now again, so when are you going to need to be aware of this? If you are writing a contract that's built, on other contracts, you're doing inheritance, you can possibly run into this. It's also kind of cool that it's mentioned in Python, because Python is, I think, if you are learning programming for the first time and you said what language to learn, I would say Python. Why do I think Python is great? It has everything that's in a modern language. You've got classes, inheritance, all the things that you're going to need to know. And it's very powerful, but the nice thing is also, the nice thing is you can run it, it's run pretty much everywhere. I've seen it run on all kinds of things, on something like an Arduino. Let's see if I have, well, it's hooked up. Some experimentation I was doing here. Let's see. There, you can see it. This is a kind of an Arduino-like thing, and I've seen it run. They use it very frequently in data science. Basically data science uses two languages, R and Python. So you can run it on these little boards. You can run it all the way up to big data science projects. So it is an excellent language to learn if you decide you want to learn programming, because it'll be applicable in pretty much what you want to do. And it's similar enough. If you understand Python, then Solidity and any of these languages we're going to be talking about should make sense to you. I'm saying this article may be confusing and unclear. Well, yeah, I mean, this is a complicated thing here. I mean, you're dealing with, this graph here, this graph here that you can look, when you first look at it, it's like, what the heck is going on here? Well, you can pull these out because they're just simple single inheritance. And this is where it gets complicated, and it becomes a matter of order. And you can go through and work through the examples here that they specify that make it very, if you understand this, then you can go through this one, and this obviously gets quite complex when you get to D, because you're dealing with multiple levels. But if you can work through these, then you'll understand this concept. So this is our multiple inheritance and the issues involved. And hopefully you found this interesting and helpful. And what I think I need to do is put a few links here in the comments, so you can take a look at these articles for yourself. Anyway, again, hopefully you found it useful. If you did, please give it a like and ring the bell and get your notifications, subscribe, and all that good stuff. And I will speak to you next time.